In this class, now I am going to discuss with you lines in three-dimensional geometry. Simply, you can call them as 3D lines. You know, students, in our previous classes, we have discussed about planes. The point of intersection of two planes is a line. Am I correct? Yes, it is correct. If you want, observe any two consecutive walls of your room. How they are intersecting? Along with a line. You are calling that line as corner of the room. Yes or no, students? Observe the two walls which gets intersection along with the line. So that is an example for a 3D line. So we write the general form of a 3D line like this. General form of a 3D line. See, a1x plus b1y plus c1z plus d1 which is equal to 0, a2x plus b2y plus c2z plus d2. So this is the general form or unsymmetrical form of a 3D line. You know, equation of a plane. This is one plane equation, this is one more plane equation. So which intersects along with a line. So that is a 3D line. So what it is? It is unsymmetrical form of a 3D line. How to convert this unsymmetrical form of a 3D line into the symmetrical form? I tell you after some conceptual points. See next. Tell me students, what is the equation of x-axis in 3D? In the 2D you learned equation of x-axis is y equal to 0 because on the x-axis y coordinate of every point is 0, hence you said there equation of x-axis is y equal to 0. In the same manner equation of y-axis is x equal to 0, whereas in the 3D also take three dimensions like this. So this is x-axis, y-axis is z-axis. This is 3D coordinate system. So on which take a point on x-axis. How it will be? Like x comma 0 comma 0. You know, you have studied in the 3D. So y coordinate and z coordinate of every point on x-axis is 0. And if you go to on the y-axis 0 comma y comma 0. If you go to the z-axis 0 comma 0 comma z. Hence, so equation of x-axis is y equal to 0, z equal to 0. Because every point on the x-axis, if you observe, whose y coordinate and z coordinates becomes 0, hence equation of x-axis y equal to 0, z equal to 0. Similarly, equation of y-axis x equal to 0, z is equal to 0. Equation of z-axis x equal to 0, y equal to 0. I hope you have understood this. Now, I am asking you to tell what is the equation of a line if it is parallel to the x-axis. So, you remember like a standard result, students. Equation of a line parallel to the x-axis is y equal to p, z is equal to q, where p comma q belongs to real numbers. Okay? In the same manner, what is the equation of a line parallel to the y-axis? Like x equal to m, z is equal to n, where m comma n belongs to any real numbers. What is the equation of a line which is parallel to the z-axis? X equal to some a, y equal to b, where a comma b belongs to any real numbers. So these are the equations of a line which parallel to x-axis, where p and q are real numbers. Equation of a line parallel to y-axis. So here you will not find y, here you will not find z, because this is equation of a line which is parallel to z-axis, in which you will not find z, here in which you will not find x, in which you will not find y. Observe that. Okay students, right, remember like a standard result. Next, I am going to tell you symmetric form of a line in the 3D. See, take this 3D coordinate system. This is an origin, this is x-axis, y-axis, z-axis. See, take a 3D line like this, and one of the point given as x1 comma y1 comma z1, and let us take a locus point P, x comma y comma z. Now I want this line equation in symmetric form. What is this? Equation of a line passing through x1, y1, z1. See, observe me students, how I am going to write this. See, drop whose projection on x-axis, let it be m. M is the put of A on x-axis. This is x-axis. Now drop a perpendicular on x-axis. So this is the put of P on x-axis. And if you extend these students, it will go like this. Okay, you can extend like this. So if you extend this PA to this side, it makes some inclination with x-axis. So that inclination is equal to this inclination, this one. If you extend PA to this side, somewhere it will make an inclination with positive direction of x-axis. Okay students, see, and here one right angle triangle is formed. That inclination is equal to this angle. You know, this line and this line both are parallel, and this will be a transversal. Hence this inclination is equal to this angle. Are you getting me students? So this I have extended. So take x-axis and extend like this. Somewhere it will make certain angle with positive direction of x-axis, alpha. So this alpha, both are equal, because these two are parallel and it is a transversal. Hence these two will be corresponding angles. Okay. Now here one right angle triangle is formed. AP, let us take this point as B. Now ABP is a right angle triangle. Now in which define cos alpha. If you define cos alpha, adjacent by hypotenuse. So let us take the distance between A and PB small r. Now you know students, so what are the coordinates of M? x1 comma 0 comma 0. What are the coordinates of N? X comma 0 comma 0. Now what is the distance from M to N? So x minus x1, from here to here x, from here to here x1. So I want this length. How much is this? X minus x1. Now cos alpha is equal to, so adjacent by hypotenuse, x minus x1 by alpha. Understood? What is cos alpha? Direction cosine. So in the DCs and DRs chapter we represented cos alpha as L. Now L is equal to x minus x1 by alpha. I think you have understood how I have written. First I took this AP projection on x-axis and I defined cos alpha. So if you take that projection AP on y-axis and if you define cos beta, so you will get m is equal to y minus y1 y minus. So students, here what is this? Here cos alpha by r, not alpha. This is r, small r. Okay. So here m is equal to y minus y1 by r you will get. So in the same manner, take the projection of AP on z-axis and define cos gamma, so that you will get n is equal to z minus z1 by r. Understood, students? How it is written, you have got it. In the same manner, if you take the projection of AP on y-axis, then define cos beta. Okay, cos beta is nothing but m in the DC's DR's chapter. Okay, so here in the same manner, take whose projection on z-axis and write this. So here make r subject, here make r subject, here make r subject. Then if you make r subject here, you will get x minus x1 by L. Here also if you make r subject, y minus y1 by m. Here if you make r subject here, z minus z1 by r. Sorry, n. So which is equal to r. Which is equal to r. R need not be written. If you want to write, you can. So this is known as standard form of a 3D line, or you can call it as symmetrical form of a 3D line. X minus x1 by L, y minus y1 by m, z minus z1 by n. x1, y1, z1 is any one point on the line, and L comma m comma n are direction cosines of that line. When the direction cosines and one of the point on the line is given, so apply this formula, so that you will get equation of that 3D line. X minus x1 by L is equal to y minus y1 by m, which is equal to z minus z1 by n. Right? Next, suppose if I give you 2 points, okay, 2 points on the line are given, then what is the equation of a line? And before that, see here, sometimes instead of DC's direction ratios will be given. Find the equation of a straight line which is passing through a point x1, y1, z1 and having whose DRs a, b, c. So then whose equation is x minus x1 by a, y minus y1 by b, z minus z1 by c. This is the equation of a 3D line passing through x1, y1, z1 and having whose DRs a comma b comma c. Okay, students? Right. Next, equation of a 3D line passing through 2 points x1 comma y1 comma z1, x2 comma y2 comma z2. So see, students, here 2 points on the line are given, x1 comma y1 comma z1, and here it is x2 comma y2 comma z2. 2 points on the line are given and asking us to find AB equation. So same, apply the previous formula. Whenever the 2 points on the line are given, how do you find whose DRs? A comma b comma c. Difference of these two. So x2 minus x1 comma y2 minus y1 comma z2 minus z1. You read this in the DC's DR's chapter. Okay, students, I got the direction cosines of this line and substitute in that, so that you will get that line equation x minus x1 by x2 minus x1, y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. So this is the equation of a 3D line passing through x1 comma y1 comma z1 and x2 comma y2 comma z2. I hope you have understood this. Right. Now, let us learn vector form of a line. Vector form of a line. See students, x minus x1 by L or small a, y minus y1 by small b, z minus z1 by small c. One 3D line is given and asking us to convert into the vector form. Now observe me how I am going to convert the symmetrical form of a line into the vector form of a line. So let us take this 3 ratios is equal to some constant lambda or small r, however you can take. So now equate these two. On equating these two, you will get x1 plus a lambda. Now y is equal to y1 plus b lambda, where lambda is a parameter which belongs to any real number. Now z is equal to, okay students, z1 plus c lambda. Now you know vector, resultant vector r equal to xi plus yj plus zk. So in the place of x, write this. If I write here x1 plus a lambda I plus y, y1 plus b lambda j, now z1 plus c lambda k. Okay, right. Now in the next step, so from all this, so what I want to take common? I, here j, here k, no? So r equal to, see this one I am going to write x1i plus y1 j plus z1 k into, take a lambda common. So if I take a lambda common, so what I will get? A lambda into ai plus bj plus ck. Now this is the vector form of a 3D line passing through x1, y1, z1 and having whose drs are a comma b comma c. In the vectors chapter, there we read this one as equation of a vector passing through this point and parallel to this vector. You read, r is equal to a plus tb bar, equation of a vector passing through a and parallel to b. Here also, this is also can be called as equation of a vector passing through a point x1 comma y1 comma z1 and parallel to a vector ai plus bj plus ck. Okay students, see this is the way to convert symmetrical form of a 3D line into the vector form of a line. What it is? Equation of a vector form of a line passing through a point x1 comma y1 comma z1 and having drs a comma b comma c. Otherwise, vector form of a line passing through this point and parallel to this vector. Okay students, I hope you have understood this. Now let us learn how to convert unsymmetrical form of a 3D line into the symmetrical form. How to convert unsymmetrical form of a 3D line into the symmetrical form. Okay students, to convert this unsymmetrical form of a 3D line into the symmetrical form, we would have to know drs of that line and also you have to identify a point on the line. If you know the point and DRs, how to write whose symmetrical form you know. Okay. So first, what is our primary duty? So they will give you unsymmetrical form of a line like this: a1x plus b1y plus c1z plus d1, which is equal to 0, and a2x plus b2y plus c2z plus d2. This is the unsymmetrical form of a 3D line. Now which we have to convert into the symmetrical form. For this, I am assuming that L comma M comma N are DRs of a line. Okay, students, and also I would like to identify a point on this line, so that I consider later. So here, what are L1 L comma M comma N? DRs of this line. So this is plane. Here for this plane, you know, actually this is what? This total combination is a line, but this is one plane, this is one plane, whose point of intersection forms a 3D line. So here this is a plane. For this plane, A1, B1, C1 are called what? DRs of whose normal. DRs of whose normal. So here A1, B1, C1 are the DRs of the normal, and L, M, N are the DRs of a line. This line and this normal DRs, both are perpendicular to each other. Both are perpendicular to each other means LA1 or A1L. A1L plus B1M plus C1N, which is equal to 0. Let it be equation 1. Now take the second one. So apply the same rule. This is also a plane, so that you will get A2L plus B2M plus C2N, which is equal to 0. This is equation 2. Now solve both of them by the method of cross multiplication. So in which first we write B1, next C1, next A1, next B1, B2, C2, A2, B2. So this is M, this is N, this is L. Now solve it. So what do you get, students? M by, so take this 4 and find the 2 by 2 det. You know how to solve these two equations? By method of cross multiplication, which you learnt in the straight lines. Same rule I am applying here. So here you get B1 C2 minus B2 C1, which is equal to N by, take this 4. So you get here C1 A2 minus C2 A1, which is equal to, so here students, L by A1 B2 minus A2 B1. So here place is not sufficient, so that I wrote here this is equal to this equal to this. Now you got L, N, M. L comma M comma N you got. What are this L, M, N? DRs of the line. DRs you got. Next you would have to identify a point on the line. What you have to do? Point on the line. How do you identify point on the line? You got the DRs. Keep it aside. Now let us identify a point on the line. Point on the line means how do you find? So you have to take, okay, L is not equal to 0. L is not equal to 0. If L is not equal to 0 means that line can't be parallel to the, if L is not equal to 0, then what do you say? Tell me, students. Okay, If L is not equal to 0, that line cannot be parallel to the xy plane. That line cannot be parallel to the xy plane. What are L, M, N? DRs of that line, no? So if L is not equal to 0, which means that cannot be parallel to the xy plane, which means that this line and xy plane both will be intersects at a certain point. Let us take that point of intersection be x1 comma y1 comma 0. This is one of the point, okay, which belongs to the line. What is the students? Point of intersection of that line with the plane. So I have taken L is not equal to 0. Okay, which means that this line never be parallel to xy plane. Now I took a point on xy plane. On the xy plane, you know y value 0. Sorry, z value 0. So this is the common point of xy plane and the line. But we people require a point on the line. We have identified. Now you got this x1 and y1. How do you find? Put z value 0 in both of them. If you put z value 0 on both of them, you will get a1x plus b1y plus d1 equal to 0. One equation, and a2x plus b2y plus d2, which is equal to 0. Now solve both of them. On solving both of them, you will get x1 y1 right here, and substitute. So in this formula, x minus x1 by L, y minus y1 by M, z minus z1 by N. So here z1 you have to take 0, y1 x1. After solving these two, you will get. Substitute here. Already we prepared LMN in the beginning. So collect that LMN and substitute here, and x1 y1 z1 substitute here, so that you get that line equation in the symmetric form. So this is the way or procedure to convert unsymmetrical form of a line into the symmetrical form. Okay students, very easy, no confusion. First we have to assume DRs of that line as L, M, N, and that line and this plane normal both are perpendicular. Hence we got that condition A1L plus B1M plus C1 n equal to 0, and that line and normal of this plane both are perpendicular to each other. Hence I got A2L plus B2M plus C2n equal to 0. I solved both of them, so that I got LMN. I kept aside, and so I assumed L is not equal to 0, which means that that line never be parallel to xy plane. Never be parallel to xy plane means that line compulsory in the 3D that intersects xy plane at somewhere. So I took a point of intersection of that line with xy plane. So on the xy plane z value 0. I got x1 y1. So in the place of z I kept to z0, so that I got these two equations. I went for solving. So I got x1 y1. You know how to solve these two equations. We have many methods to solve. Substitution, elimination, cross multiplication method. Many methods are there. Solve it and obtain x1 y1 and come back and substitute here, so that you will get symmetric form of this unsymmetrical line. Okay students, next see parametric form of a line. See, parametric form means simply you have to see this is a symmetrical form, x minus x1 by, so you can take it as L or A, y minus y1 by M, now z minus z1 by N, which is equal to, shall I take as R? So that R may be positive or negative, we don't know. So now x equal to, what do you get, students? Otherwise take your mod. If you remove the modulus symbol, you can take plus or minus. So see here, convert. See, I want x equal to, what do I write? x1 plus r. If you remove the modulus symbol, you have to write plus or minus l. Plus or minus r into l. Now y is equal to y1 plus or minus rm. Now z is equal to z1 plus or minus rn. So this is called what? Parametric form of that line. So where do we use this parametric form? In the straight lines also we have got. So in the 3D they will give you one line, OX, OY, OZ. One line will be given to you whose DRs or DCs will be given to you. Whose DCs, L, M, N are called what? Whose DCs? DCs of the line will be given to you, and they will give you a point, fixed point. A, whose coordinates are x1, y1, z1. And they will ask us to find 2 points which are maintaining a distance r units away from A. That point may be above A or below A on this line. So that point may be here or here. Both maintains same distance. Here this side r units, this side r units. If you take plus here, you will get this P. If you take minus here, you will get this Q. So in such type of applications, we use this parametric form of a line equation. X equal to x1 plus or minus rl, y equal to y1 plus or minus rm, z is equal to z1 plus or minus rn. X, y, z is a locus point. It can be anywhere on the line, but here we require a point which maintains r units away from A. Either that point may be upside or downside. Okay students, r will be given to you and DCs of the line will be given to you, and simply go for substitution and simplify. You get P and Q. I hope you have understood the meaning of parametric form of a line and how does it helpful you in the application part. Right. Now let us go to learn angle between the two lines. Angle between the two lines. See, x minus x1 by A or A1, y minus y1 by B1, z minus z1 by C1. This is one line equation which is passing through a point x1, y1, z1 and having drs A1, B1, C2. Here one more line is given, x minus x2 by A2, y minus y2 by b2 and z minus z2 by c2. So it is passing through a point x2, y2, z2 and having drs a2, b2, c2. Now somewhere they may intersect. Okay na students. So which are intersecting means which belongs to the same plane. So if the lines belongs to the same plane, which may be either parallel or intersects. If they belong to the different planes, which never be parallel, which never be intersects, you know that lines belongs to the same plane are called coplanar lines. What we have to call them? Coplanar lines. Lines belongs to the same plane. If you would like to draw two lines on the same plane, how it can be? Either those may be parallel or those may be intersects. If the lines belongs to the different plane, which never be parallel or intersects. Observe that point. If the lines belongs to the different plane, which can be called as non-coplanar lines, or you can call them as Q lines. Lines belongs to the different plane are known as Q lines or non-coplanar lines. Observe that. Now see students, so these are coplanar lines and asking us to find angle between them because they intersects. What we have to understand about those two lines which are intersecting lines, coplanar lines. See, use this formula cos theta is equal to, so this line DRs are known to you, A1, B1, C1, this line DRs are known to you, A2, B2, C2. Now cos theta is equal to A1, A2 plus B1, B2 plus C1, C2 whole by root of A1 square plus B1 square plus C1 square and A2 square plus B2 square plus C2 square. You read in the DCC DRs chapters. There you learnt whenever the DRs of two lines are given, how to find angle between them. Same formula we use it there. Whenever the two lines intersect each other, so one is acute, one is obtuse. Okay, here I kept the modulus symbol. In such case we get acute angle unless they intersect 90 degrees to each other. If they intersect 90 degrees to each other, cos 90 is 0. Bring it to the left side so that you get A1 A2 plus B1 B2 plus C1 C2 is equal to 0. When do you get that? Whenever they intersect 90 degrees to each other, put theta 90, bring it to the left side. Cos 90 0, 0 into something 0, then it becomes A1 A2 plus B1 B2 plus C1 C2 equal to 0. Okay? Right. Next. Suppose these two lines are parallel. Parallel means, you know, whose DRs are proportional. A1 by A2 which is equal to B1 by B2 which is equal to C1 by C2. The two lines are proportional, then two lines are parallel, then their DRs are proportional to each other. Next, one plane and one line is given. How do you find angle between them? This is the plane. Now one line is moving like this, penetrating through the plane. What is the angle between the line? Okay, this is the line. And line equation you know, x minus x1 by a. Otherwise you can take as L. Y minus y1 by m. Z minus z1 by n. Where L, m, n are DRs of this line. And plane equation you know, ax plus by plus cz plus d equal to 0. I would like to find angle between the line. Here it is going like this. Angle between the line and the plane. Means, so this angle is the theta. Okay students. Okay. Right. Now see. Here, A, B, C are called what? DRs of whose normal? Like this. This L, M, N are called what? DRs of this line. If it is theta, theta is the angle between the line and the plane. But how much is this? 90 minus theta. So, cos of 90 minus theta. 90 minus theta is the angle between the normal of the plane and the line. What is 90 minus theta? Angle between the normal of the plane and the line. But what is theta here? Angle between the line and the plane. Okay? So here whose DRs ABC, whose DRs LM. Now here mod of AL, apply the previous formula. Because whose normal DRs are ABC, line DRs are LMN. Like same like A1, A2 plus B1, B2, C1, C2. Apply the same formula for this. Here AL plus BM plus CN by root of A square plus B square plus C square into root of L square plus M square plus N square. So you know cos of 90 minus theta which is equal to sin theta. Now sin theta is equal to modulus of AL plus bm plus cn whole by root of a square plus b square plus c square into root of l square plus m square plus n square. So you people can apply this formula to find angle between the line and the plane. Here also students, suppose if this line is parallel to the plane, if this line is parallel to the plane, what do you get? If this line is parallel to the plane, then this line will be perpendicular to the normal of the plane. If the line is parallel to the plane, then this line will be perpendicular to the normal, no? Perpendicular to the normal. In such case, what do you get? AL plus BM plus CN is equal to 0 you will get. Whenever this line is parallel to the plane, then you get this condition. AL plus BM plus CN equal to 0. Where ABC are the DRs of the normal. That normal of the plane and the line both will be perpendicular to each other. Hence AL plus BM plus CN equal to 0. If this line is perpendicular to the plane, then this line and whose normal both are parallel to each other. A by L, B by M, C by N. This condition you will get. No confusion students. When do you get this condition? Whenever the line is parallel to the plane. Parallel to the plane. Hence AL plus BM plus CN equal to 0. Why we are getting this condition? Because if this line is parallel to the plane and a line and a normal of the plane both are perpendicular to each other. Hence A1 A2 plus B1 B2 plus C1 C2 equal to 0. If this line is perpendicular to the plane, then a normal and this line both are parallel. Parallel means whose DRs are proportional. Okay students? Right. Next. See students, see one line. See, two lines will be given to you. Whether these two are coplanar lines or not, how do you check it? How do you check it? See, x minus x1 by a1, y minus y1 by b1, z minus z1 by c1. This is one line. And one more line is given, x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. Two lines are given. Whether these two are coplanar or not, means belonging to the same plane or not. How do you check? So by this datum, x1 minus x2, y1 minus y2, z1 minus z2. Here a1, b1, c1, a2, b2, c2. If this det is equal to 0, then which belongs to the same plane, means which are coplanar lines. So here x1, y1, z1 is a point on this line, x2, y2, z2 is a point on this line. So take the difference of x coordinates, y coordinates, z coordinates, and here write a1, b1, c1 are the DRs of this line, a2, b2, c2 are the DRs of this line. So you know how to evaluate the 3 by 3 determinant of 3 by 3 matrix. And if this is equal to 0, hence you can say that both are coplanar lines, means belongs to the same plane. Okay students? Right. Next, see, sometimes, okay, here both are given in symmetrical form. Like this you need to check. So sometimes second line, they don't give you in symmetrical form. They don't give you in symmetrical form. They will give you in unsymmetrical form, like a1x plus b1y, c1z plus d1, which is equal to 0, is equal to A2x, B2y, C2z plus D2. And here you can take this drs as LUMUN, because you may get confusion between this A1 B1 C1 and this A1 B1 C1. So that you take like this. Okay students, now this is a line in symmetrical form. This is also a line but in unsymmetrical form. Both belongs to the same plane or not. Both are coplanar lines or not. How do you check means, see this x1, y1, z1 you need to substitute in the plane equation, first plane equation. So a1 x1, b1 y1, c1 z1 plus d1 by this a1l plus b1m plus c1n. This you have to write here, which must be equal to. So this x1, y1, z1 here you have to substitute. In the place of x you have to write this x1. A2 x1, B2 y1, C2 z1 plus d2 by this A2l, B2m, C2n. Okay students, so if this is same, then both are coplanar lines. No confusion here. Just get x1, y1, z1 and substitute in the first plane. Wherever x, y, z is there, there you have to write x1, y1, z1. This you get by, so a1l, b1m, c1n. Now go to this a2 x1, b2 y1, c2 z1 plus d2 by a2l plus b2m plus c2n right here. If both are equal, then you can say that both are coplanar lines. This is the way to check whether the given lines are coplanar or not. Whenever one of the line is in symmetrical, one more line is unsymmetrical form is given. Okay students? Right. Next. Two skew lines are given. Two skew lines are given. Those may be given in symmetrical form or they may give you in vector form. Suppose here x minus x1 by a1. Okay, y minus y1 by b1, z minus z1 by c1, x minus x2 by a2, y minus y2 by b2, z minus z1 by c2. Both are skew lines. Skew lines means which belongs to the different planes. Different planes means they never intersect, they never be parallel. Okay students. So between these two skew lines, there at certain place perpendicularity is possible. So the perpendicular distance between these two is the shortest distance. So which we have to measure. Find the shortest distance between these two skew lines. This is the question. Shortest distance between the skew lines, non-coplanar lines, which belongs to the different plane. So here I am going to give you a formula. Follow that, which is very very important. Shortest distance between skew lines. See, mod of, this is mod of determinant of x1 minus x2, y1 minus y2, z1 minus z2 by a1 b1 c1, a2 b2 c2 mod whole by square root of. So here, shall I put summation symbol? Summation B1 C2 minus B2 C1 whole square. You know the meaning of summation. So here A1, B1, C1, A2, B2, C2. Here only combination of B and C I wrote. When you remove this sigma symbol, you have to write plus CA combination plus AB combination. B1 C2 minus B2 C1 whole square plus C1 A2 minus C2 A1 whole square plus A1 B2 minus A2 B1 whole square. If you apply this formula, you get the shortest distance between these two skew lines. Very easy to remember. Based on this, you expect a question in the competitive exam. Either it may be mains or any other competitive exams like MSET, or this is also useful in advanced exam also. So every year in the advanced also, either in paper 1 or paper 2 or in both, we are getting one question from this 3D and vectors. Okay students, I hope you have understood this formula. So sometimes they will give you this skew lines in vector form. Like this they will give you. See here, a vector R equal to A1 plus, so like lambda B1, R equal to A2 plus mu B2. Both are skew lines. Now what is the shortest distance between these two? Means you would have to do A1 minus A2 or A2 minus A1 dot B1 cross B2. So apply magnitude by modulus of B1 cross B2. This is the shortest distance between skew lines. So simply you can find the, here what is this? A1 minus A2. A1 and A2 both are vectors. Take the difference of these two and find the dot product with cross product of B1 and B2. Okay students, this is a vector passing through A1 and parallel to B1. Passing through A2 parallel to B2. Both are non-coplanar vectors, belongs to the different planes. Now what is the shortest between these two vectors? Means apply this formula. So this is nothing but a box, no? So determinant of box of A1 minus A2 B1 comma B2. Box means simply you have to find the det by mod of B1 cross B2. If you take the difference of these two, so it should be written in first row, and this is second row, this is third row. Then find, evaluate 3 by 3 det for this. How to evaluate a box of these three vectors, you know, and it may be positive or negative. If it is negative, because we are finding the distance, hence it should be treated as positive. For that sake only I kept here modulus symbol, and by mod of B1 cross B2. Even this should be also treated as a positive value. You know, absolute value, modulus always a positive. Okay, right here units. Okay students, I hope you have understood this. Sometimes they will give you coplanar lines like this. R equal to A1 plus lambda B. R equal to A2 plus lambda B. Both are coplanar vectors or coplanar lines. What is the distance between these two, which are parallel? It is a one vector passing through A1 and parallel to B. It is a one vector passing through A2 parallel to B. Means both are parallel lines. Now measure the distance between them. So distance between the parallel lines or parallel vector which belongs to the same plane. Distance between coplanar lines. Coplanar parallel lines. Distance between parallel lines which belongs to coplanar lines. Students, see, same like previous one. So how do you find? B cross A1 minus A2 by modulus of B. Apply this formula. B cross, students, magnitude of B cross A1 minus A2, and here put one mod also. So this is the magnitude of cross product. Here this is not required, because if you find B cross A1 minus A2, you get a vector. Cross product of two vectors is a vector, and find whose magnitude, positive only, by mod B units. So this is the way to find shortest distance between parallel lines. In the parallel lines, wherever you find the distance, you will get same, but that should be shortest. See, like this, not like this, like this. So distance between the parallel lines means which you have to measure as the shortest distance. Use this formula. Mod of B cross A1 minus A2 by mod B. So this is the complete concept of 3D lines. I hope you have understood. So this concept helps you in your G mains preparation or in IIT advanced preparation. So this 3D lines syllabus is not there for local level entrance exams like EAP set and other private universities exams, but mostly questions can be expected in mains and advanced from this 3D lines. But compulsory you need to learn this 3D lines also, because so this is a connectivity between vectors and 3D lines. Hence in the local level exam, engineering entrance exams also, this chapter is very useful. Thank you students. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Thank you one and all.